Welcome to Autodesk University 2020, everyone, and our annual Tech Trends event, which we're doing virtually for the first time. Tech Trends is an event where we invite all of our important partners and sponsors to share with you what they think the future holds for you and how it's going to enable your businesses to be more competitive, more creative, more innovative. I'm Scott Burdine, Chief Technology Officer for Autodesk. Joining me here today are Jeff Wood from Lenovo, Bruce Blaho from Hewlett-Packard, Christian Lang from Enscape, Frank Sokwe from Intel, Julian Faure from Unity, and Mike Haley from Autodesk.
There's a complexity involved and an ecosystem involved when we bring products to market. And no one person in that ecosystem, no one company in the ecosystem can deliver it all by themselves. And this requires a ton of collaboration, a focus on usages, the work from silicon manufacturing to products that our customers put out to end-to-end software and services. Now you're talking about the developer ecosystem as well as the cloud service providers. And then on top of all that, a complexity of interoperable and open standards. And this is highly important, right? That the ability to tap into a wide variety of partners and develop products that can come time to market and are interoperable and open standards and meet the needs of the customers is absolutely imperative. Working together puts the right, tension on us from a timing perspective. We got to get, technology out there. We got to focus on the usages. I mean, a lot of those things come to bear from different perspectives and different elements to create the amazing solutions that you use today.
Our customers are reliant on the whole partner ecosystem, the software, the hardware, and the support that goes with it. It's always been important for us to curate solutions, the right software, easy to access and use on the right hardware configuration. But as COVID-19 has driven our customers home, they're on their own and simultaneously cut off from their IT staff. In addition to software as a service and hardware, we think at HP that services are critical, especially in supporting workers at home. COVID has driven people to work from home, but even when the virus is defeated, we expect that many workers are going to continue working at home more than ever. To see an example of what I'm talking about, check out HP Business Boost. HP's Business Boost offering bundles together hardware, security, support, and services, all provided to customers for a fixed monthly payment.
It's a challenge as our customers are trying to manage remote systems. All of their end users are remote now. There's pretty much no one in the office. There's some folks that are starting to move back into that office infrastructure, but there's going to be a new normal as we go into the industry. Even as the pandemic gets under control, there'll be a new normal. There'll be a hybrid model of remote versus on-premise solutions. So it's super important for us to be integrated from a hardware and software perspective and offer a seamless solution for our customers. So we work very closely with Autodesk, making sure that we fully support and performance tune Autodesk-based software solutions, as well as fully support and from a certification perspective. So we've got a full team of engineers that are very focused on the Autodesk suite of solutions, from BIM to PLM to everything else that's going on in the industry. It's super important for us to have a flawless and highly reliable solution for our customers that they can deploy and trust their solution in that environment.
Our customers are highly reliant on an ecosystem today of hardware solutions combined with SaaS and numerous other technologies. As we see cloud mature, we're seeing customers adopt cloud, but that doesn't mean that there isn't still a reliance on technologies on the desktop as well. So that means that even though your data may be sitting up in the cloud, it still means that you are sitting at a device and you are interacting with that data. So the power and the visual fidelity and the interaction frequency of that device is paramount to the overall experience a designer is having. When you look at technologies like VR, AR, when you look at visualization technologies, new kinds of interactions, GPU power on the workstations, display technology. All of these factors in hardware are going to become more and more important as the power in the cloud also increases and enables these more sophisticated design environments. So that's why Autodesk is really happy to have this partner network that we work with that are providing these fantastic hardware solutions. The other aspect of partners that I like to think about is in the cloud itself. So often when our customers are working with the cloud, it's not apparent what they're actually working with at a hardware level. But we know that when we are working with our cloud providers, the technologies that are available in the cloud, such as high-performance computing, such as GPU, networking, and storage technology, is also paramount to those solutions being viable in the cloud.
So at Unity, we partner and integrate with a very large number of SaaS applications. In fact, we have a deep partnership with Autodesk, and recently we announced an integration with ESRI, with ArcGIS, to bring geospatial data into Unity. We also have partnerships with a large number of hardware vendors and cloud service providers. So we meet our clients based on the type of solutions that they need. But at the core, Unity is a development platform. So we help a large ecosystem of ISVs, system integrators, agencies, and value-added resellers build their own products, build applications that they sell to their end customers. And so we are very committed to enabling that large ecosystem, and we help them monetize. In fact, we resell some of the applications they build. We also have a marketplace where we can distribute the content that they create. But we also help on the technical side by making sure that the product they build work on any platform. In fact, we support more than 20 different platforms today.
I think a partner ecosystem is extremely important because the buildings and the structures we build today are incredibly complex and require a rich and varied set of solutions to support the processes behind them. Customers will continue to look for the best solutions for each step of the process, and they rely on solutions that work together. Take an example, cloud platforms like BIM 360 and Construction Cloud, they have helped converge much of the information, and the applications that's using this data will need to integrate well. A typical architect's office, for example, is going to have a wide variety of solutions and hardware on-site that all needs to work together well. With Enscape, we want to provide a consistent visualization interface to any product the customer chooses. No matter what combination of products they choose, they have a common way to see their work in a high-quality, real-time view.
You know, it's just been a crazy 7 or 8 months with this COVID pandemic, and it's just changed the way all of our customers are working. You know, we've seen a general trend with our AEC and product development customers adopting hybrid workflows with local BIM and PLM solutions on the desktop, and even using shared data in the cloud. You know, for us, in many cases, this accelerates collaboration, allowing everyone to work on common data models. And always, you know, the data is always up to date. And what's very interesting is that keeps the data secure in the data center as well. So it's not that big of an issue for security issues. You know, but while cloud data-centric approach works for many customers, it really isn't one size fits all. We're also seeing others pushing virtualization to the next level. You know, we've introduced the P920 rack workstation last year, and we've been partnering with Macdyne with their TGX software to do remote collaboration, remote visualization. And that's a great way to connect even our ThinkPad mobile workstations. It's a perfect client solution accelerated by NVIDIA's RTX graphics solutions. This drives, again, a secure solution as data never leaves the data center.
In order to understand how COVID accelerated the reliance on SaaS and cloud platforms, we need to first understand why it's occurring now as a response to COVID, rather than as a natural progression of industry work models. Design practices have traditionally relied on centralization of human resources due to analog processes associated with traditional delivery, for example, making of physical models or printing drawings. And secondly, due to the value of frequent in-person communication with the many stakeholders of design or construction projects. So with the restrictions imposed by COVID, these criteria become challenges and the industry must respond to that. So analog processes are replaced by digital workflows and in-person communication is replaced with video calls, such as we are doing right now. So the decentralized nature of SaaS and cloud platforms make these solutions accessible and allow all parties to still meet the same goal of the criteria as mentioned, just using different means and methods. These tools and technologies existed pre-COVID as well. The difference between the current climate and that of pre-COVID is that now everyone must make the digital transition. It isn't just an option for the pioneers or the innovators in the industry.
Top of mind questions very quickly go around. What about software as a service? What about cloud capabilities? What about other things that are really going to help us with this ability to do real-time collaboration, especially when you think of a workforce that's distributed both domestically and globally. And COVID has really accelerated the need in areas like remote security, manageability, the communications infrastructure, end-to-end, the ability to access data and the ability to produce and collaborate from a diversity of locations. And the whole idea behind software and services, this really must adapt to this kind of new normal that's been emerging. Pure cloud models are very, very challenging. The file sizes involved with segments such as AEC or data science or media and entertainment. A lot of our customers are finding 100% cloud-only based workflows can be expensive, and they have concerns about where their data and their data security is, the network access and latency are challenges. And on top of that, with companies like Autodesk, this constantly evolving and performance set of evolving workloads. So from a customer lens, they're really looking at this at the expense of OpEx versus CapEx. How do I invest in hardware? How do I invest in services for the right balance of cost and business continuity? And at Intel, we think of this as a need for a hybrid model. This is about end-to-end, cloud to client, and we recognize that need. And to that end, we're really focusing on cloud to client technologies that help users and IT decision makers actually manage those concerns.
Our customers have found themselves in a situation with all of a sudden a large stay-at-home workforce, such that their original behind-the-firewall local network solutions were no longer sufficient to support a stay-at-home workforce. So in that case, cloud solutions where the data is centralized and the workflows are accessible from anywhere become not just a nice to have, but actually become essential. So we've seen significant adoption of our BIM 360 construction cloud, for example, tools in the building and building design space, construction space, as all of these professionals are at home. Now, what we've also seen with COVID is a change in attitudes towards various parts of the design and make lifecycle. We have been talking about flexible manufacturing for many years. In other words, the ability for our customers to quickly pivot to making different things on demand and also to making those same things at vastly different scales. What a lot of our customers discovered is that it was actually quite hard to do that. Once COVID really began to hit, there was a realization that the adoption of tools that enable adaptive manufacturing and adaptive scale of manufacturing were really important. Additionally, our customers also began to rethink their supply chains and how they wanted to think of well-established supply chains as no longer all that well-established, and that those supply chains could actually be quite easily disrupted with something like this global pandemic we're all living in. So that has also created the need for more flexibility in how they design their manufacturing workflows, how they manage them, and how they will manage them going forward, even after COVID.
COVID has significantly accelerated demand for real-time technology. The first use case is marketing and sales. Interactive, augmented reality, shopping experiences work. They actually sell up to 10x higher conversion rate when you display a product online in a way that's interactive, that's personalized, that's in augmented reality. The second area where we see a real acceleration with COVID is a real-time collaboration. And imagine the power of bringing 100 different stakeholders in a single environment and look at a product or a design idea at the same time. I would say the third area is e-learning. Students can't go to school anymore, and a lot of professionals are looking at learning a new job. And we see millions of individuals right now learn on immersive e-learning platforms. And something that we've discovered that's really interesting is that we all learn in a different way. We're all unique. And virtual reality, when applying artificial intelligence, helps customize the training course in a way that's highly unique to the need of the individual. And the last one that's really important to us right now is training of frontline workers in virtual environment. Many of our customers have developed VR training courses to train healthcare workers on how to use protective equipment.
Back in March when COVID struck, like many others, most of us at HP started working at home, and so did our customers. Getting cut off from their office technology and simultaneously cut off from their IT support staff was crippling at first for a lot of our customers. But fortunately, HP just happened to be introducing a new remote access platform called zCentral. It enables our customers to work from anywhere. Well, most importantly, it enables high performance apps like video editing, visual effects, 3D modeling, what have you, to run with full acceleration back in the office, in the data center, or any place. So while we were expecting a general ramp up as customers evaluated casual work from home scenarios, COVID came along and suddenly our customers were completely dependent on these kind of technologies. And that long feature backlog list that the engineering team was expecting to address over, say, the next year, suddenly that was on fire and it was needed right now. So thanks to some monumental efforts from our customers and our engineering teams, transition's been very successful. In fact, we just won an Engineering Emmy Award at HP for our work to save Hollywood, as one of our customers put it.
Data and platform solutions can offer us a more holistic understanding of a project. It tackles the issue of fragmentation, which has always been prevalent in AEC. Our customers rely on a wide variety of solutions to complete their design. Increasingly, they are looking for ways to simplify and centralize the number of different places where they hold key information. The core strength of Enscape is that it integrates directly into products like Revit, so all the data remains inside the design solution. And when it comes to automation, it's again all about the data. So with centralized, structured, trustworthy data, we can deploy automation with a higher value proposition. If we trust the data, then we can trust that the automated process will behave identically between the various points of data. However, I think we must be careful that we don't automate bad design. Automation should uplift and inspire, and it should give us the opportunity to expand our understanding of each other.
Like Autodesk, we see many of our Lenovo customers striving to create better designs with fewer resources. As a workstation OEM, this is exciting for us because many of the software processes and innovations create challenging workflows for us to push solutions to the limit. We're also seeing a greater adoption in generative design workflows to solve design and building challenges based on predefined rules. Some customers employ AI algorithms that refine each design iteration for even better outcomes. What's interesting to me is, there's a big move in robotic automation. Previously, we've seen robots in manufacturing for many years, but now they're coming out of the manufacturing facilities into our everyday lives. What's really cool is I've seen, even last year, we had our customer React Robotics at AU, where they showed a prototype of their dog bot, if you remember that. And it could be programmed to do a variety of tasks. Think about the opportunities scanning site conditions for on-premise evaluation or even safe access to disaster recovery sites. What's interesting to me is they're going to continue to challenge the way we innovate in this area.
Where we've seen data and platform solution impact our customers the most is in the area of machine learning and AI. So as our customers move their machine learning and AI models out of the lab and into production, they're realizing there's more to it than just making a model, training it, and running it on some platform. As with software, machine learning models need to be updated, fixed, retrained, and so on. The opportunity is to create automated processes to manage this. Some people are calling it ML ops for machine learning ops because of its similarity to DevOps that's used for software very broadly. The goal is to create continuous integration, continuous deployment systems for machine learning, much like we have for software. If you'd like to see a great example of ML ops, take a look at ForestFlow. ForestFlow is a Linux Foundation incubation project created on a base of work done at DreamWorks Animation to automate their own internal machine learning deployments.
A lot of what we do these days is driven by four main customer needs. The need to connect the digital and the real world by creating what we call real-time digital twins that help understand how products and buildings and infrastructure actually used in the real world, to prevent downtime, to do predictive maintenance, to get real-time feedback from end consumers on how products are used. The second need that we see is the need to create real-time collaboration experiences. We help bring together designers, engineers, contractors, suppliers into a single immersive environment where they can look at a design idea, at a model, and together and run scenarios. The third need that we see is we want to create interactive and intelligent products. And one thing we do there is power the interactive experiences you see on every screen. Whether that screen is the dashboard or the navigation system in a car, or the screen on a vacuum cleaner, or the device to control the temperature in your apartment. So the runtime behind those screens very often is a Unity runtime that's optimized for that screen. And the fourth one is the real demand today to create interactive marketing and shopping experiences. We now buy online, I guess, with COVID, and a lot of customers demand support to create shopping experiences that are more interactive. So for example, to see how a couch in augmented reality is going to fit in your apartment, or to configure your car and choose the right colors, the right trims, and maybe drive that car eventually, on your preferred road along the coast.
Data and platform are really critical to Autodesk's future, specifically in providing workflow-level solutions to our customers. Historically, Autodesk has been known as a company that's been successful by providing solutions, specific solutions, throughout the workflow cycle of our customers, but never really connecting all those together into a coherent workflow. Now that we're focusing on a platform that's in the cloud and specifically is driven by the data that is being transferred through each stage of that workflow, we are in a much better position now to truly solve our customers' end-to-end workflow problem. There's normally a lot of overhead in typical workflows, which you can really begin to take away that burden from our customers by moving it into a data-centric platform that sits in the cloud. So that transfer of information is no longer apparent. Now, once you have data and a platform in the cloud, what it also means is you can now begin to apply insights and automations to that data. You can bring value inside those workflows that were really not possible before. Autodesk cannot build every single specific solution within everybody's workflow. We don't have the domain expertise to do all of that. However, what we can do is we can provide the platform and the workflow environment such that others can build those solutions and offer them through our workflow environment, which means that our customers then get this complete end-to-end workflow with all of the right and necessary tools throughout it.
I mean, first and foremost, it comes down to understanding the workloads. the images, the files, the simulation sizes, movies, streaming, the audio components of that. These are all workloads that just put a ton of pressure on the platform. So Intel's focus on this as a platform solution. It's more than just any single element. It's the sum of the elements, whether it's the CPU, graphics, memory, storage, communications technologies. All of these things really have to fire in concert if you're really going to have a performant and responsive system. So thinking about Autodesk software users and their demand, I mean, some of the things they need absolutely have to have the smoothest capabilities, and that means using all of the platform elements. I'm really going to talk a little bit about Optane persistent memory. At a high level, this is just about large file sizes. Think about simulation and large file sizes. If I had to load those again and again and again, it just burns up a lot of time. And this really speeds up people's productivities, or Optane SSDs, speeding up access to data. There are workloads like artificial intelligence and data science that also operate on these huge data workloads. And when I think about it from a platform perspective and a CPU perspective, things like putting more instructions per clock, which is fundamentally improving the CPU architecture, and things like frequency that scale with almost every application, or implementing a feature like Intel Turbo Boost Max or Intel Deep Learning for AVX instruction capabilities on AI workloads. And then on top of all that, we have to think about this from a deployment inside of an enterprise environment. And this is where our technologies like vPro come into play. It saves the business a ton of time and money being able to manage and secure these type of devices, especially when you think about what we do now. We're working from home. They have to be secure, they have to be managed, they have to be safe and up all the time. And this represents opportunities for our customers, of course. These are opportunities that are about the hardware itself, the PC itself, as well as what I'm seeing is end-to-end workloads and workflows. Intel Silicon spans, cloud to network to the client side of things. And we start thinking about how can we improve telemetry in that kind of environment, or latency, or quality of service, as well as how do you figure out distributed compute and disaggregated workloads. This is how our customers think about it. They use these performant platforms in areas of data analysis or data science to help their customers build higher-end systems and platforms where their value added and differentiation is now software and services for those customers.
So as data-driven computing grows very rapidly, a whole host of issues are arising in the areas of trust, ethics, and security that we have to grapple with. How do we keep data private when it may not even belong to us, such as patient data or 3D models driving our additive manufacturing factories? How do we ensure that our AI models are not biased, such as facial recognition systems that only work with light-colored skin? So as computing becomes more distributed, we're seeing rapid growth in edge computing installations. And in these cases, the compute nodes may be running in what we call zero trust environments, such as the back of a grocery store or a hospital. So how do you secure those devices when they're not in a secure data center? How can we trust them and what's running on them before we push out our precious software in our customers' applications? How can we protect the customer's proprietary data? So at HP, our approach is to start with the most secure endpoint devices, which we've been building for years, and use that as our root of trust. So a hardware-based root of trust is much more secure. Over time, we're going to extend those capabilities to build off of that root of trust to include solutions with multiple machines running in zero trust environments, authenticating each machine, authenticating the workloads that they're running, the data being stored, and the data that's in use. In addition, over time, we expect to see ways to secure and authenticate the AI models themselves, the data that was used to train them, and the data that we're using for the inferencing.
Unity has a strong culture of customer first. So generally speaking, we go above and beyond the standard market requirements to raise the bar for the rest of the industry. When it comes to privacy, we believe in a world where privacy is a right. And that's why we give a lot of tools to control the privacy settings to users and developers. You may not know this, but Unity is a very large ad network. It's actually one of the largest ad networks in the world. We deploy 22 billion ad impressions monthly to help our game developers monetize their games. And to do so at that scale, we take privacy very seriously. In fact, we're one of the first ad tech companies to be CCPA compliant. And we have solutions to manage GDPR and opt-ins and consent. And very early on, we made a decision to never collect personal sensitive information. When it comes to security, I mean, there's a reason why big enterprise accounts across government, aerospace, automotive, or energy are trusting Unity as a platform. We do a lot of things around security, but let me give you one example. We invest a lot in machine learning. And instead of making the requirements for our customers to send their data over to our machine learning system, we actually give the option to deploy our simulation and AI services on-prem on the client system, so their data actually never leaves the environment.
Autodesk as a company is fortunate in that we have based our business on building solutions for our customers. Our primary focus is to provide the right tools to help our customers get a job done. Our job is not to sell customer data or derivatives from customer data to others in any way. So that puts us fundamentally from the beginning in a good position to actually build a trusting relationship with our customers. Now, Autodesk has a long history of working closely with our customers on all sorts of solutions and shifts in technologies and shifts in the industries. So many of our customers already work with us on those shifts. So we tend to have trusting relationships that we can continue to build upon as it shifts more into a data realm. Now, once we are in this data realm, one of the things we've discovered is the best way to really achieve trust with our customers is to put value at the top of the equation. If our customers are not getting value from Autodesk, then it's very natural and totally expected for them to begin to question how we are using their data. As you move beyond that, you move into the realm of data ethics. And at Autodesk, we've started to think a lot about data ethics. In fact, internally in Autodesk, we have adopted a code of data ethics that drives us towards things like accountability, holding ourselves and our vendors accountable for how they treat data, our customers' data at every step of the process. Another example is fairness and bias, making sure that when we do use machine learning and AI technology, that the results that come out of that are equitable at the end of the day. They are not reflecting entrenched biases, say, in us or in the data itself. And the last one I'll mention is openness and agency. We want to be incredibly transparent in how we use customers' data so that they can see what we're doing and why we're doing it. And then we give them control. We give them the ability to say, yes, use my data for that, but not this.
You have to have an ecosystem of trust and security built that you can operate on. And this applies to both hardware and the software ecosystem. When we think about building tools for creators, such as like what Intel and Autodesk are doing, we really have to work together on open standards that span a lot of these segments, end markets and consumption platforms. And there's some ongoing work in this space. Adobe's actually started the Content Authenticity Initiative. And this is in partnership with Twitter and New York Times. And the original goal was to help identify and prevent the dissemination, for example, of fake news. But as soon as you think about security, I mean, you think about how broadly you can apply this, it's also shifting a bit to include tracking of content authorship, like attribution and ownership. And, Intel's been invited to and is participating and proud to participate in this Content Authenticity Initiative.
So as far as customer and privacy data, we strictly follow the GDPR guidelines put in place in 2018. Perhaps our German heritage is an advantage here because Europe has legislated that customer data belongs to the customer and they should control how it is shared. So we treat all of our customers around the world the same way here. So what challenges, risks, and opportunities do we have? We must think ahead and try to understand the implications of our decisions with a critical eye towards privacy and security. We must ask what could go wrong in addition to what will this improve. But this, as most challenges, is also an opportunity. We don't have to solve this challenge by ourselves. We can engage our customers to help us solve it and build a better relationship in the process. The demands of today's market are not likely to be the demands of tomorrow's market, and we need to stay in constant dialogue with our customers to ensure we are meeting their dynamic needs and priorities as they evolve. Above all, we need to make sure that we are not building a collection of features, but instead solving valuable business problems for the customers. So building an ecosystem of trust and collaboration, I think some level of transparency needs to exist. Open source, just as an example, is well trusted because of its transparency. We may not be able to reach that extreme of transparency, but we need to at least take a step in that direction. Opaque platforms and processes do not build trust, and they do not harbor accountability. We also need to make this a collective effort. Expecting one party to police themselves does not have a high amount of trust or value in it. Instead, a committee of various stakeholders can be much more effective at implementing and checking for standards which impact the collective.
We at Lenovo, we take security concerns of our customers super seriously. I've heard even since the beginning of the year, there have been over 300,000 unique online threats detected. So we have to be on our guard and we have to provide the tools for our customers to ensure that they have a very secure solution with respect to their operating platform. We developed our ThinkShield platform to address these security concerns in a very integrated manner, through a transparent integration of hardware and software solutions. From device protection features like privacy guard filters, camera shutters, even full disk data encryption. Even beyond that, to threat detection, to robust cloud solutions and remote update of systems. All these things are very critical in this environment. So, think about the IT departments trying to manage remote systems all around the globe now with their users being at home or in remote solutions. At Lenovo, we build trust with our customers in this rapidly changing world, and our ThinkShield platform is the trust that they can provide as they deploy that in their environment.
Many of our customers across automotive, consumer product, or AEC are approaching us to get help on creating smarter, more intelligent products, more intelligent buildings, smart cities. So one of the areas that we are investing in right now is simulation. And a lot of these customers are using Unity to train the machine learning algorithm of their autonomous systems virtually in an immersive environment. An example is BMW. They drive 95% of their test miles virtually in Unity's platform to train the autonomous system of their car, to bring to market self-driving vehicles a lot faster. So let's look at why they're doing that. Imagine the amount of time you come across in the real world an edge case like a pedestrian crossing the street during a storm at night where you have very little visibility. And that's a scenario that can be rendered with 1 million of variations virtually in Unity's platform to generate the amount of data, sitting data that's required to properly train the car on how to react in this kind of situation. They know that's really safe.
BIM and digital twins have become standard across the process, whether you're doing design, construction, or operations. Visualizing 3D information is becoming increasingly important, not only within teams, but also to clearly communicate information to all stakeholders. So model sharing between phases still needs improvement, but we think at the design and pre-construction phases we'll continue to share more and more model data. So real-time realism, VR, augmented reality, 3D-centric collaboration, they will become standard working modes rather than reserved for specialized technology. We are learning right now that in-person activities can often be replaced with high-quality, immersive 3D experiences. Owners, designers, builders, they will adopt this deeply over the next decade. We will continue to come together in person for many reasons, but meetings and work that can be done more efficiently in a virtual space will increasingly adopt 3D technology.
There are several key trends that we're tracking and have embraced as we design and develop our workstation solutions for our customers. Certainly in AEC and product development, quite frankly, it's all about mobility right now because everyone's working from home or they're doing remote capabilities. I've got a customer who said, heck with it, I'm moving to Aruba for 6 months just to get away and I can still work remotely, right? But they're really pushing us for thinner, faster, lighter solutions for their users on the go. And what's great is, even last year, we introduced our P53 mobile workstation, 15-inch form factor, but it was the first of its kind to integrate the new NVIDIA Quadro RTX 5000 graphics. So all of a sudden, you can have a 15-inch form factor with the performance of what you used to have to carry a big 17-inch solution with the big power bricks and everything, right? So remote connectivity, people on the go, still getting the performance they need from that perspective. We're also seeing, probably a convergence of construction and manufacturing workflows. Many of our customers see buildings of the future being manufactured rather than constructed. A good example of that are good friends from MX3D. They're about to install the world's first 3D printed bridge in Amsterdam. And it's really a cool solution. They've been using our Lenovo workstations to do all their design and development of that solution. It's out on the web. You could check it out. The other thing that's really interesting to me is there's a big move for visual and virtual communication in real time. A lot of the projects right now are being reviewed with VR, MR. It's becoming more common in the industry from that perspective. I think one of the best examples of that I've seen recently is, our partners Vario, just a fantastic headset out there for MR capability. I saw a demo at one of the shows recently where I sat virtually in the interior of a Volvo, a brand new Volvo, right? And I could see my hands, touching the dash. I could pick the colors that I wanted in the dash. I looked at the leather seats. The visual fidelity, even down to the stitching on the leather seats, was just phenomenal. And what's even more exciting is, we've just introduced the fastest rendering solution in the industry. Our new P620 workstation, based on AMD's Threadripper Pro technology, now is the fastest rendering solution out there because it has Gen 4 PCI Express capability. This is twice the performance of the standard Gen 3 architectures out there today. And with the new introduction of NVIDIA's new RTX A6000 graphics card, that combined with the new P620 will be the fastest rendering solution on the market. We'll see these customers, they have an insatiable demand for performance, and they're just going to absolutely love this product because it's going to make them far more productive than they have previously.
So as we look to the future, look to the horizon, for the last several years, cloud computing has dominated the IT discussion, and for good reason. But the last few years, we've seen an explosion of data generated mostly at the edge, everything from cameras in retail stores, IoT sensors in digital factories, multiple sensors in self-driving cars, all are examples. So in parallel, we've seen amazing growth in data science and AI capabilities. That gives us the tools to take all that data, glean insights from it, and then build models that can predict future outcomes and control systems. So like when an expensive piece of equipment is going to need service or when it's likely to fail, for instance, the heavy compute needs to run at the edge. There isn't time or bandwidth to move all those terabytes or more. Plus, if I lose my network connection, what happens to my factory or my store or my car? And what do I do if my data is too private or too valuable to risk moving into the cloud? So for these reasons, we expect rapid growth in the coming years for edge computing. But what about all our cloud-based workflows? The cloud's going to remain critical, and it's going to grow rapidly as well. So at HP, we think the answer over the coming years is going to be hybrid edge cloud solutions, workflows that can run microservices both in the cloud and at the edge as needed, wherever it makes sense for them to run. And they need to be flexible, able to run in anybody's cloud in multiple edge locations with a variety of hardware.
A lot of times I get a chance to focus in my business, to focus on, Frank, what you're delivering in the here and now is, pretty awesome, but how are you thinking about this long term? What kind of changes are on the horizon? And, how do I think about my innovation priorities and my customer needs? Now, I'm going to channel Bob Swan a little bit on this one. He laid out a challenge for the company for the next decade, which is all about enriching the lives of every person on earth, whether it's a business person, a consumer person, or anywhere in between. That is the focus. And the way we think about that focus is this increased demand for computing power at many levels. In essence, the demand for high-speed processing of data on all types of products are going to drive our Intel strategy, whether it's PCs or servers or auto or industrial IoT. I mean, we just think about anything that needs compute power in the future built on the products that our customers deliver and innovate on. So fundamentally, when I think about what's driving our business, we're anchoring on 6 pillars: the CPU, the GPU, memory, interconnect, security, and then the custom software that brings it all together end-to-end and cloud to client. And that's really what's driving our business strategy.
There's a number of opportunities that lie ahead for us to innovate over the coming 5 to 10 years with our customers. A lot of the opportunities revolve around data and how we process data, so providing automations that remove tedious tasks for our customers. So much of design and creation work involves doing operations over and over again that are the same old well-trodden paths, that we can now build intelligence into our software, automations into our software that really take away a lot of that activity and provide more time to our customers to be truly creative. Another thing that we're beginning to see is the emergence of digital twins. And digital twins has been a topic that's been in the industry for quite a while, but really we're beginning to see digital twins truly come to fruition now, with data, cloud, and computation all being available at very large quantities. What it also allows us to do is to begin to look beyond the traditional limits of digital twins. And by this, I mean exploring things, for example, like human behavior. If you think about it, most design in the world is about creating something for human beings. It's about creating an environment and for them to live or to work or to thrive. Or it is about creating products for them to utilize. Or it is about creating entertainment for them to interact with. It's all about a human at the end of the day. Yet, very rarely in design software do we actually help designers optimize their solutions specifically for humans. And the reason being is that humans are complex. Our bodies are complex. The physics of our bodies are complex. How to hold something, how to grab something is a complex function. How we behave in a building, in a group. During COVID, this has become a very important factor. How do a group of people potentially transmit viruses to each other in a closed environment? That is a human behavioral thing as well as a biological function, right? The last thing I would say about digital twins is a good digital twin is largely measured by how accurate it is when compared to the real world. So one of the ways you can make a digital twin more accurate is by measuring the real world and bringing that data back into the digital twin on a constant basis. So you're effectively correcting the accuracy of the digital twin to more accurately represent the real world. So this sort of feedback cycle of real world back to the digital twin, physical to digital if you want, is going to be a very key aspect in our innovations in the future. And a lot of that now is driven by the explosion in sensors and the ready availability of different types of sensor technology that can also be connected into cloud environments.